grade 12 learners, welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Now today we're going to be looking at analytical geometry. I know you've already started with this topic. So we're going to look at the grade 10 and the grade 11 analytical geometry, because that forms the basics of the pre-knowledge that you're going to need for you to understand the grade 12 analytical geometry. Now, the objectives of today's lesson is the following. Now, after the completion of this session, you must be able to, in other words, you must be able to determine the distance between the 2 points. You must be able to determine the coordinates of the midpoint of the line segment joining the 2 points. You must also be able to determine the equation of the straight line joining 2 points. Remember, in grade 10 you also did that. Determine the equation of the line through 1 point, and parallel or perpendicular, very important, parallel or perpendicular to a given line. So in other words, the lines will be parallel or perpendicular. We need to be able to get the equation of the line through that 1 point. Calculate the angle of inclination of the line, where m is the gradient, equals to tan of theta, the gradient of the line. So m equals to tan theta is the gradient of the line there. So the formula will be given there as m equals to tan theta. Then we must be able to get the angle of inclination there. So you see how we're going to do it in the activities that follow. Now, actually, what is this analytical geometry that we are doing here? It is nothing else but it is a mathematical subject in which algebraic symbolism or symbols and methods are used to represent and solve problems in geometry. In other words, we are going to have the geometric figures. You see, we have geometric figures. In this case, we have a parallelogram there. We have a square there, we have a rectangle there. So you can see those geometric figures. We are going to try and work out the symbols, the values of the coordinates of those points by using this analytical geometry. So analytical geometry is nothing else but we are going to use the algebraic methods of solving the geometric figures. So we have the geometric figures. We want to solve those geometric figures by using the analytical methods, which is algebraic expressions. Right. I've got 4 formulae in there. So these are the grade 10 and the grade 11 formulae. So you can see we have the first one is the distance formula. Please, this formula will be given to you at the end of the year. You don't need to memorize them, but you must just know how to use them. So the distance formula is x2 minus x1 all squared plus y2 minus y1 all squared, and we need the square root of, because it's the distance that we're looking for. The midpoint formula is m, it equals to that. So we've got x1 plus x2 and y1 plus y2 all divided by 2. So that one is divided by 2, that one is divided by 2. Remember, these are coordinates. So if I work them out, I must get a coordinate x and y. All right. The next one is the gradient formula, which is m equals to y2 minus y1. Copy it correctly. We're still having then as we're writing it incorrectly, even when the formula has been given. So let's copy it incorrectly. We still have learners who are writing x2 minus x1 over y2 minus y1, which is incorrect. It is the change in y over the change in x. So we have the change in y over the change in x. So it must be the change in y over the change in x. Now the last one is the gradient. It's equal to the tangent. That's where we need to find the inclination of the line. So you can see that I've missed out one formula, which is the straight line formula. But the straight line formula is from the gradient formula. So in other words, we can create a straight line formula by using the gradient formula. If I take this gradient formula and say m equals to y2 minus y1 all over x2 minus x1. So if I cross multiply this, then I'm going to get y2 minus y1 equals to m into x2 minus x1. So remember, if I'm given a point, so I can still write this y minus y1 equals to m into x minus x1. So I can write it like that. So if I'm given a gradient and a point x1 and y1, I'm able to get the equation of the line, and we will do this in some of our activities. So the straight line formula is nothing else but coming from the gradient formula. So the gradient formula. So if I do not have a gradient here, so it means that I'm going to have y minus y1. I'm only given 2 points. So I'm going to have y minus y1 equals to y2 minus y1 over x2 minus x1 into x minus x1. So in other words, that part here is the formula for the gradient. And then we have a point that we're going to use, and the x and the y will remain there in the formula. Okay, so you must know this formula. You must work with this formula in the activities that you're going to be doing, and then try and understand which one is going to work where, because sometimes you find that you're using the wrong formula because you do not understand which formula goes where. So that you understand the question, but you don't understand which formula to use. So if it's distance formula, then you use that. If it's midpoint formula, you use that. Gradient formula, there's the formula. Inclination, we use that. So inclination is nothing else but the angle. So you find the question that says determine the value of theta. So theta will be an angle in that case. So you must be able to work that out. Now let's go to the activities. Now in the diagram, triangle ABC. So first of all, we need to read the statement, and if the information that is in the statement is not on the diagram, so we can put that in. So in this case, A, it's minus 6 and 4, it's given there. B, it's 2 and 2, and C is minus 6 and minus 2. And we have the angle of inclination. Can you see angle of inclination there? BC is that. So that angle, the formula that we use for M equals to tan of theta or tan of beta, tan of an angle, we only use it when we have the line, that angle formed between the line and the x-axis. Can you see the angle is formed between the line and the x-axis? That's when we use that formula. Okay, so where we have our Cartesian plane, that angle cutting on the Cartesian plane, so that's where we use that formula. I cannot use that formula if I'm looking for angle A. You see the angle A there, it's too far away from the x-axis. Now the first question says determine the gradient of AB. So the gradient of AB, what do? I go to my formula sheet and then I try to locate what is the formula for the gradient, and I'm using the point A and the point B. So I need to find the gradient of that line AB. So the gradient of AB, I can write it like this. It's equals to, so remember I'm going to take the y2 value. The easy way to write it will be to write yb minus ya over x of b minus x at a. Please do not swap the values. So if I started with a b, then I must start with the b on the y, on the x and the y. If I start with an a, I must also start with an a on the x coordinate. So now if I say y at b, means that I go to the b coordinate and locate the y value there. So the y value is 2. I go to the a value, I locate the y at a, which is going to be 4. Then I go to the x at b, which is 2. And then I go to x at a, which is -6. Remember, the formula has got a negative. So I'm going to get -2 over 8. Because negative times negative gives us a positive. 2 times 6, 2 plus 6 is 8. And the simplified answer will be 1 over 4. So the gradient of AB is going to be -1 over 4. Okay. All right. So that's an easy 3 marks. So this type of questions you really need to get it. So you have the coordinates of A, the coordinates of B. Use those coordinates to get to the gradient. B says determine the coordinates of D, the midpoint of AC. So you can see we don't have D in our sketch. So I go to my sketch, they say it's a midpoint, so it must be somewhere there. Why I'm doing this? Because I want to check if the answer that I'm going to get will align with what is happening with on my Cartesian plane there. So the midpoint, if I need the midpoint, remember I need the midpoint of that. So I'm going to have the coordinates. So how am I going to write down the coordinates? Remember, it's going to be x at B, x at A, sorry. So that D cannot be there, sorry, it cannot be there because it's AC. So let's check AC. So AC, it must be somewhere there, so the D will be somewhere there. Right. So I'm going to say x at A plus x at B over 2 x at C, sorry. And the other coordinate will be y at A plus y at C all over 2, and that will be the coordinates of the midpoint. So remember, it is a D, is a midpoint D, so I'm going to have x at A will be -6. Remember, we are adding, so we are adding a -6 over 2. Then I'm going to have y at A, which is 4. And y at C, we are adding a -2 all over 2. The coordinates of D are going to be -12 divided by 2, it's -6. 4 minus 2, it's 2. 2 divided by 2 is 1. So the coordinates of D is -6 and 1. Now what can I say about that line now? Can you see we have a -6 there, we've got a -6 there, we've got a -6 there, so meaning that that line will be a straight line, which is parallel to this line, to the x-axis. Okay, but that question was not asked. So what was asked is the coordinates of D. So it's -6 and 1. Okay, so now we know the coordinates of D. The coordinates of D is 6 and -6 and 1. Now the next question is asking us the equation of the straight line BD in the form y equals mx plus c. So already I have the coordinates of D. Can you see? And that's a nice thing about analytical geometry, that these questions are scaffolded. In other words, what the answer that I got at B, I'm going to use it at C, because already the value of, the coordinates of D, I have them there, so I'm going to use them here. So I'm going to say, because I need the equation of the straight line, first of all, what do I need? Here, I need the gradient of that line BD. I also need the y-intercept of that line. What do I have? I have 2 points. So if I've got 2 points, what can I start with? With the gradient. So I'm first going to get the gradient of BD. And the gradient of BD will be 2 minus 1 divided by. So remember, is the y value minus the y value there. So I'm going to have the x values will be 2 minus into -6. So I have the y value minus the y value and the x value minus the x value. So I'm going to have 1 over 8. So the gradient of BD is 1 over 8. But remember, I'm not done. What do I need? I need to get the equation of that line. So to get the equation of the line, I can use any of the points. To be safe, because we need to be safe here. To be safe, let's use the coordinate of the one that has been given at B, because that one I might have made a mistake, then I make another mistake again. So let's avoid this one that you calculated. Let's go with that one which is given. So I'm going to say y minus y1. Can you see that that formula now comes back from the gradient? Then we have y minus, so remember I'm now using the point B, which is 2 and 2. I've got my gradient, I've got a point. So y1 is going to be 2. The gradient is 1 over 8. We have the x1 is 2. So I'm going now to simplify that. So I'm going to have 1 over 8x. If I multiply this out, and this 1 over 8 multiplied by negative 2, I'm going to get 1 over 4. Then I transpose this negative 2 this side, I get a plus 2. Then my y value is going to be 1 over 8x. And then if I add this, I'm going to get 7 over 4. So if I want to make sure that this line is correct, I can see that this line here goes like that. So it's increasing, increasing, increasing. So the gradient is fine. It's a positive gradient. I can check this. This point here, it's going to be, this point there, it's going to be 2. And this point somewhere there can be 7 over 4, which is the same as 1 and 3 over 4. Okay, so which is very close to 2. So I can see that my answer is very correct because of what I've done on the sketch, what I've indicated on the sketch. On the sketch, I can see the point there, it's next to 2, there's a 2, and it's a positive value. The gradient is positive, the graph is increasing. So I'm definitely sure that I am correct. You can see how I can then make sure that my answer is very close. If I get a negative gradient, it means that my graph must be going this way. And if I get a negative y value, it means that my value should be somewhere there. So that cannot be correct. All right. Now the next question says we need to determine the distance between point B and C. So we need point B and point C, and we need the distance there. We need to get the length of that line. That's an easy one. So to get the distance of BC, remember I need the square root. So I'm now going to get x at B minus x at C squared plus y at B minus y at C all squared. Okay, so now I'm now going to substitute. So x at B, so if I check x at B, it's 2. X at C, it's negative 6, so it's negative 6 squared. I've got y at B, it's 2. Y at C, it's negative into negative 2 all squared. Right, so I'm going to get 2 plus 6 is 8. 8 squared is 64. 2 plus 2 is 4. 4 squared is 16. I'm still inside the square root. And if I add this, I'm going to get an 18. And I can write this one as 4 root 5. Okay, so That's my final answer. So the distance from B to C, it's going to give us 4 root 5. Right. So some of the formula, you'll find that they've written a square here. So in other words, if I've got a square, I must square both sides. So in this case, the square is not there. So BC will be equals to 4 root 5. Okay. Right. I think we're doing well. The next question talks about inclination. Can you see all? Now we have used almost all the formula that I had at the beginning. So we are now using the inclination angle theta. We need that theta. It is between the x-axis and the straight line. So we are going to use that our formula for the gradient m tan of theta, where the tan of theta will now be equals to the gradient. So now what do we need? We need the gradient. We don't have the gradient of BC. I don't think we calculated it anyway. So we need the gradient of BC first to do this one. So to get a gradient of BC, you must remember we start with the y value. It will be 2 minus 2 all over 2 minus into minus 6. So we're going to get the gradient of the line, which is going to be 4 over 8. So the gradient of that line will be 1 over 2. So now we know the gradient of the line. So I can come here and then say tan of theta will be 1 over 2. So for me to get the value of theta, I'll get the tan, and then from there I write 1 over 2. Then the angle, I use the arctan of theta, which is going to be shift tan 1 over 2, and the angle that we're going to get there is 26.57. Right. Okay. And I can see that this is an acute angle, so I'm correct. That angle is between 0 and 90 degrees. Okay. We're going to take a 2-minute break before we continue with our next activity. Right, let's continue with our activities. We have this one. Now, this one needed a little bit of a break. The value of, hence calculate the size of angle C. Now we can see now that angle C is far away from the x-intercept and the straight line. So we cannot use, now listen to me, we cannot use the gradient formula. The gradient is equals to tan theta formula. Now this is where you use our, this is where we use our knowledge of geometry. Now first of all, I can deduce that that angle there is 90 degrees. Why? It is 90 degrees because we remember that this one is -6 and that one is -6. We had a D at -6, and that line is a straight line which is parallel to that, to the y-axis. So that angle there will be 90 degrees because that line is perpendicular to the x-axis. So to the x-axis, right? So already I've got this angle here. It's 26.57. Now my knowledge of geometry tells me that this angle here and that angle there will be equal because they are vertically opposite angles. So which means that that angle here will be 26.57. Right. Now already I have a 90, I have 26.57. I can get this one here. Okay. So my angle C is going to be 90 degrees minus 26.57. Easy. So can you see I did not use the formula tan theta equals to the gradient. So now I'm going to have my C, angle C will now be equals to, if I subtract this, I get 63.43 degrees. So this angle here will now be 63.43. So if I add this 90, I add this, I add that, then I get 180 degrees. Or here I would have said 180 degrees minus 90 degrees minus 26.57. The answer will still give me 63.43 degrees. Okay, right. So that is your grade 10 and grade 11. Remember in grade 10 you have done the distance formula, you have done the midpoint of the line, you have done the equation of the straight line, but now you're just using the gradient and a point. Now here we're now trying to revise that work that you have done, because the exam, the final year exam, grade 11 analytical geometry is plus minus 15 marks, and we really need to get these marks. Right. Let's look at the next one. Now the next one says we need to read and understand the question, but mostly we know how to do this question, but sometimes we don't read the questions, and then from there we end up writing wrong things. Now determine the equation of the straight line. So already what do they want? They want the equation of the straight line. So the equation of the straight line is y minus y1 equals to m into x minus x1. I already know that this is what they want. Okay, right. Now, and they say which passes through point D. So, okay, point D, do you still remember point D? Point D was -6 and 1. Now there's one question, and they say it is parallel to AB. So we need a line which is going to pass through this point D, but that line should be parallel to that. So that line should be parallel to that. In other words, it must be parallel to that AB. See, I'm drawing something there so that I understand what I'm doing here. Now, what do I understand by the lines that are parallel? The gradient of this line 1 is the same as the gradient of that line 2, because the lines are parallel, so the gradients will be the same. Do I have the gradient of AB? Yes, I do, because the gradient of AB, I got it in A. So the gradient of AB, I know is negative 1 over 4. I already calculated it in point A, number A. So now, the gradient of this line, if it's 1 over 4, negative, which means that the gradient of that line will also be negative 1 over 4. So no problem. Which point am I going to use? I'm going to write down the gradient of the line which is parallel will be negative 1 over 4. Now, I'm now going to also use the point D, which is negative 6 and 1. So I'm going to substitute now. Y minus point is 1. The gradient is negative 1 over 4. X minus x1, that will be plus 6. Okay, so y plus 6 because it's the negative and the negative for the 6, for the negative 6. Okay, so if I write it down quickly there, I'll multiply out there, I'll get negative 1 over 4x. I'll multiply negative 1 by 6, I'll get minus 3 over 2, and then I transpose the negative 1, so I add it to a negative 1, and then the answer that I'm going to get is a negative half. So that is the equation of that line. Now I want to check if that will be true. The gradient of this line is a negative gradient. Remember, the graph is decreasing, so we've got a negative gradient, so my gradient will be fine. Can I check the y-intercept? Can the y-intercept be negative 1 over 2? Yes, it can be correct here. So I have negative 1 over 2 as my y-intercept. So I think I am correct. Okay, and I'm definitely sure that actually I am correct actually. Okay, because then I can see that those values, they are very close to what I've drawn on the sketch. Okay, all right. Now that is the end of activity number 1. So that question, it's one question that we've taken from the past paper, and you can see the number of the marks there. There's about 13 marks, so we must definitely grab those marks. Those marks are not difficult. We really need to make sure that we understand and try to practice on all those things that those questions that are pertaining to the analytical geometry. Now, activity number 2. Similar things. Questions will be basically the same, changing the numbers only, but you need to read the question. Points A, B, and C are given. So point A is there, point B is there, point C is there. QM. Now, terminology is very important. We must read and understand. We must understand these terminologies. QM is a perpendicular. So in other words, it's perpendicular, which means that it's 90 degrees. Bisector means that this line here will be the same as that line there, which makes the M here the midpoint. You see that? Because if I don't understand that, I will not be able to answer questions that follow. Let's look at the question. Or they say, and Q lies on AC produced. Okay, the Q lies on AC which has been produced. Now the first question says, let's determine the gradient of AB. Now the gradient of AB. So we go to AB. We say the gradient of AB is equals to. So I'm going to have at A gradient, I start with the y values, so it will be 9 minus 3 divided by, so it's my 9 minus 3. So if I say 9 minus 3, I must then use the 7. So it will be 7 minus 9. So I'll have 9 minus 3 is 6. 7 minus 9 is negative 2. The gradient is negative 3. So you can see if the gradient is negative 3, am I right? Yes, because the the line there, it's a decreasing line, so the gradient should be negative. Okay, that's so easy. So the gradient of AB, I write it like this, will be negative 3. So that's 2 marks. Okay. The coordinates of M. Now they never told me that M is the midpoint. Right? But now I know, because there was a sentence that says QM is a perpendicular bisector. So I've already talked about that. That and that will be equal, so meaning that M will be the midpoint. So in other words, they're just trying to trick you there. We must get the midpoint of that line, which is going to be 7 plus 9 divided by 2, and it will be 9 plus 3 divided by 2. So the point that we are looking for is the M point. So 7 plus 9 is 16. 16 divided by 2 is 8. 9 plus 3 is 12. 12 divided by 2 is 6. Let me see if I'm correct. I think so, because that point there can be 8, and this point here can be a 6. So it means passing there. So that point can be a 6. So my point there can be 8 and 6. So I think I'm fine. You see, and if I get funny answers like, you know, your -4, -8, or -6, I must just know, no, there's something wrong that I've done. Because according to my sketch, those values cannot be correct according to my sketch. Because the M is in the first quadrant, the X value must be positive, the Y value must be positive, then I must get 2 positive values. Right. And I can see this is 8, and that point here it's 9, so that should be correct. Okay. At this point there it's 6, that point there it's 7, so I think I'm fine. So if I get the values that are above 6, the others values that are above 8, so I know there's something wrong that I've done. I must revisit my answers and rework them out and see if I can get that correct. Now, the next activity, C, it's the equation of MQ. Now the equation of MQ, so what should I do? I must look at MQ, yo. Then at M, what do I have? I have 8 and 6. At Q, I don't know what the values are. I just know that this line is perpendicular to that. This line here, it's equal to that line there. Can I get an equation with only one point? No gradient. Now, so what should I do? Try to figure out what must I do there. Because we are told that this line here is perpendicular to that, it means that I need the gradient of that line and multiplied with the gradient of that line to get -1. Remember, if the lines are perpendicular, the gradients multiply to give us -1. So in other words, gradient of line 1 times gradient of line 2 will give us -1. In other words, it's the reciprocal of the other one. We then change the sign of the other gradient. Now, so what do we need? We need the gradient of MQ times the gradient of AB must give us -1. But what do I know about the gradient of MQ? The gradient of AB. So the gradient of AB, I think we got it somewhere. The gradient of AB was -3 times the gradient of MQ. That must give us -1. So if I make gradient of MQ the subject of the formula, I'll get 1/3. -1 divided by -3 will give me 1/3. Now I have the gradient, and I've got a point. My point is 8 and 6. Lovely. Now I can use my formula. Y minus y1 equals to m into x minus x1. No problem now. because I have a point y minus 6. The gradient is 1 over 3. The other value is 8 here. So I'm now going to work out that. So I'm going to have y equals to 1 over 3x. 1 over 3 times negative 8, it's negative 8 over 3. If I take negative 8 over 3 and I add it to this to this 6, the answer that I'm going to get will be plus 10 over 3. Alright, so let me see if I'll be correct. I'm talking about this line here. Increasing function, can you see? The gradient is positive. So I just want to show you how we check that the answers are correct or not. The gradient is positive because that line there is increasing. 10 over 3 is a positive value, so the y-intercept of the graph can be 10 over 3. Positive. Okay. 10 over 3 is 3 and a third. I know that this point here will be a 3. Y value there will be a 3. That point there can be a 3 and a third. So I can now see that I am correct. So analytical geometry, it's nice because they have a sketch and you try to, to draw the sketches, these equations on the sketch, the ones that we are looking for, and see if that could be correct. The values that I'm getting are close by to what I do to the sketch that I've drawn. Okay. All right. Nice question. So can you see that my challenge might be if I did not understand the word perpendicular bisector. So if I did not understand that, I will not get the value, the coordinates of M. I will not get the equation of MQ. See, I will not get, I'll basically not get full marks in this question if I did not understand the word perpendicular bisector. And it is used very much often in analytical geometry. Please watch out for that word. Now, still in activity 2, we have this question here, determine the coordinates of Q. And that question, they had 7 marks. Nothing to be scared of. 7 marks, nothing to be scared of here. So let's look at what we are supposed to do. Remember, we have got the equation of this line here, right? I'm going to write it here. The equation of that line was 1 over 3x plus 10 over 3. There's the equation of this line, right? Now, I see this point here is also on this line here. But do we know the equation of AC? No, we don't. If I know the equation of AC, I can then equate the two graphs. Oh, now you can see it's quite easy. So now I can equate the two graphs. So I can then say, first I need the gradient of AC. To get the gradient of AC, I'll say it's 9 minus 6 divided by, started with a 9 minus 6, so it will be 7 minus 4. So 9 minus 6 is 3. 7 minus 4 is 3. My gradient is 1. Now I need the equation of this line here. Y minus y1, m into x minus x1. So remember, I need the equation of line AC. Okay, so now I'm now going to substitute y minus, I can use this point. I think that point will be much easier for me. Y minus 6. The gradient of AC I already got, it's 1. I've got x minus 4. Then I'll have y equals to x minus 4 plus 6 will give me a plus 2. So I'll have this equation here. And now I'm going to write down this other equation here. What do I do with these two equations? I'm going to equate them. Why do I equate them? Because they're equal at the point Q. So I'm going to equate these two. So I'm going to say 1 over 3x plus 10 over 3, it's equals to x plus 2. Because can you see they're both equals to y? Then I can work out this. I'll say 1 over 3x minus x equals to 2 minus 10 over 3. What? If I work out this one on my left hand side, the answer that I'm going to get there will be x equals to 2. That I think you can do. Just a simple algebraic work that you need to do there. Okay. Right. So the x value will be equals to 2. But remember, I don't need the x value. I need the coordinate. So already I've got the x value. So if I take this and I substitute it in there, I'll get the y value, which is going to be 2 plus 2, which is going to be 4. So the coordinates of q will be 2 and 4. Okay. So now, let me check if I'm correct. So if this value there, it's 3, there it's 3, the q value there can be 4. That's fine. The y value there, so the x value there can be equals to 2 because that value there is 4. So the 3 will be in between. So I know I'm done with that question. And it's 7 marks. So there was nothing very difficult in that. We needed to find it. We know that is why I said the previous question said determine the equation of MQ. Then we are using the equation of MQ. We need the equation of AC or AQ, equation of AC or AQ to get the two equations, equate them, solve for X and Y. Okay. All right. Now, that next question says, determine analytically, because we can still do this geometrically, but they're saying analytically that this line here must be connected, and we need QA, this line QA here is equals to QB, that these two lines here are equal. For them to be equal, because they've said analytically, it means that I'm now going to use the formula that are in analytical geometry. Other way to do it will be to make sure that you get these two angles to be equal. These angles must be equal to that, but that will be a big challenge for you. So that's why they stated it categorically that use analytical methods to do that question. So that should be easy. So we just need to get what? The length of QA. First calculate the length of QA. Length of QA. So now the length of QA will be, check this. QA, we already know the coordinates of Q, it's 2 and 4. Can you see? So whatever you've got in previous question, we're going to use it in the next question. So we're saying the coordinates of that is 2 and 4. QA, it's 2 minus 7, or we can start with the 7. 7 minus 2 squared. Then we are going to say 9 minus 4 squared. And the answer that we're going to get there is 5 squared is 25. 5 squared is 25. Square root of that will be square root of 50. Right? And we know the square root of 50 will be, we can write it as 5 root 2. Right, simplified. Doesn't matter, you can still leave it as square root of 50, it doesn't matter. Then I must then get QB, the distance of QB. So the distance of QB, remember I want to prove that those lines are equal. Okay, so QB, I'll say 9 minus 2 squared. Then I'll say 3 minus 4. I said 9 minus 2. So I'll say 3 minus 4 squared. So I'll have 7 squared, it's 49. Minus 1 squared is 1. So this is square root of 50, and it's 5 root 2. And I can then say therefore QA is equals to QB, and that is what I needed to determine analytically, that those two lines are equal. Obviously, for me to prove that two lines are equal, what do I need? I just need the distance formula, because I'm proving the lines that are equal. Okay. We are going to take a break for 2 minutes before we continue with that last activity. All right, welcome back. Activity 2 continued. Now, this question here, it's 2 marks. Now, it says, determine the coordinates of D. I don't have D on my sketch, but they told me that ABDC is a parallelogram. So in other words, I must know what a parallelogram is. I must know what are the properties of the parallelogram. But I'm going to do it differently now. I'm going to do it by using the analytical methods, using the X and the Y values. So here I'm now going to just indicate where I'm just going to put a letter D somewhere. Then I'll have that. And they say this is a parallelogram, so I'm just going to do that. Don't mind my diagram, doesn't look like one, but it should be a parallelogram. We must get that point D. Right, so now I'm going to put D, X, and Y because I don't know what the coordinates are. Sorry, that line is not correct, so I must put this one there. It must be D. Sorry, that should be like that. Now it's correct. Okay, so now that line is not correct. So now I can see that that is a parallelogram. So this line parallel to that, this line must be parallel to that, but I must get the coordinates of D. Now I'm going to use the diagonal. So I'm going to use this diagonal here and that diagonal there. I'm going to show you a very simple way of doing it. Now I'm going to say the sum of the x values. Now listen carefully here. The sum of the x values of diagonal 1, I'm going to write this one as diagonal 1, this one as diagonal 2. So the sum of the x values of diagonal 1 is the same as the sum of x values of diagonal 2. So I'm going to say the sum of x values of diagonal 1 will be the same as the sum of x values of diagonal 2. Right. So now I'm going to write them down now. So I'm going to start with diagonal 1. So diagonal 1, it's x plus 7. Remember, it's x plus 7. I'm talking about the sum. So of diagonal 2 will be 9 plus 4. Then I'll get x, it's equals to 13 minus 7. So my x value will be equals to 6. So the same way as I've done with the x values, I'll do it with the y values. I'll do it with the y values. So I'll then say with the y values, so the y plus 9, it's equals to the 3 plus 6. So my y will be equals to 9 minus a 9. The y values will be 9. So then my coordinates of D are going to be 6 and 0. The other way to do it will be, the gradient of this line, it's equal to the gradient of that line. Remember, they're parallel lines. And the gradient of this line is also equal to the gradient of that line. Remember, they are also parallel lines. So I can then find the gradient of this line, and I get the gradient of that line. Then I get the gradient of that line and the gradient of that line, and then I solve for x and y. So what I'm talking about here is that I'm going to have the two gradients. The two gradients are the same, so I'm just going to write alternative here. Right? So I then can say y minus 6 over x minus 4 with the gradient will be negative 3. I think I already got the other gradient. The other one will be y minus 3 over x minus 9, that is equals to 1, because I also got the other gradients. So the gradients of this line I already have. So therefore I'm then going to multiply out. One equation that I'm going to get will be y minus 6 equals to negative 3 x plus 12. The other equation that I'm going to get will be x will be equals to y plus 6. So I can get this. So in this equation, that one will be this one and that one will be that. So I can just substitute there, minus 3 into y plus 6 plus 12. Then my y value, if I can work this one out, my y value will be 0. Then if I substitute a 0 there, my x value will be 6. So the coordinates of D will still be 6 and 0. So I can do it alternatively like that. So I can have my two equations, and I can also have those two together. So now I can be able to there are other methods that you can use to do that, but I just wanted to show you these two, because sometimes you find that you're not given it as a parallelogram, you're given it as a square, so you really need to work your way around this question. Okay. Right, activity 3, which is our last activity. It's got a lot of questions in there. Nice question here also. In the diagram below, points A, B, and C are the vertices of triangle ABC. P is the midpoint. Can you see now we are given that this is now the midpoint, so I don't have a problem with that. For BC, AB, can you see that we are not told that Q is a midpoint? We're just told that P is a midpoint, so that is not a midpoint. I love how they've put the angle in there, the angle beta there, right? They say AC, it's parallel to this line. So already I know that the gradients of those lines are equal. Now, the first question says, determine the gradients of AB and BC. So, first I need to get the gradient of AB. The gradient of AB will be a 9 minus a 5 over 3. Remember I started with a 9, okay? So I'll have a minus 9 minus 3. So I'll have a 4 over negative 12. And I'll have a negative 1 over 3. I know I'm right. This gradient there is a negative gradient. That line is decreasing. Then I must get the gradient of BC, which is 5 minus 1. Then we have a 3 minus a 1. So I've got a 5 minus 1, and I've got a 3 minus 1. I need BC. So therefore I'm going to get a 6 over 2. The answer will be 3. Oh, I know where they're going with this answer. Okay, right, we have got a 1 over 3 here. Check this. We've got a 3 there. Already I can see you smiling and saying, now they're asking a question, is B 90 degrees? Is this angle here 90 degrees? They say justify your answer with calculations. They don't want you to explain, to write a story. So we want you to justify by using your calculations, by calculation. So I already know the gradient of AB is negative 1 over 3. I know the gradient of BC, which is 3. What happens if I multiply the gradient of AB by the gradient of BC? So I'll get negative 1 over 3 times 3, and our answer will be negative 1. What do I know if I multiply two gradients and I get negative 1? Therefore, that means that AB is perpendicular to BC, which makes B angle to be 90 degrees. See, it's justified by calculation. So in other words, I know the gradient of this line is negative 1 over 3. I know the gradient of this line is 3. Multiply these two together, that angle will be 90 degrees. Okay, right. Now they want us to determine the beta, the angle of inclination of line AB. Can you see they also explain that it is for line AB? And that line here means this line there, it's parallel to this one. You see? So if it's parallel to that, then we have that angle that is there. So the angle here that is formed is the same as for being formed far away there. If I extend that line there, that angle will be parallel to that. Because this line is parallel to that, the angle that is going to be formed there will also be will be a corresponding angle. So it will be corresponding angles will be equal. So in other words, to get that angle there with that dotted line, it simply means that our Cartesian plane will be there. Can you see? So that angle that we're talking about is that angle there. So right. So how do I then get it? I'm going to get the gradient of AB. For me, it's just to get, because they said AB. So I just need the gradient of AB. So how am I going to get the gradient of AB? So the gradient of AB, I think I have it somewhere. Do I have it somewhere? Gradient of AB? Yes, I do. Because the gradient of AB, we've already worked it out, is 1 over 3. Then I need the tangent of this angle, beta, which is negative 1 over 3. So beta will be equals to 180 degrees minus tan arctan of 1 over 3. Can you see I did not write negative 1 over 3. I only wrote 1 over 3. So which means that there will be 180 degrees minus the angle that I'm going to get, which is 18,43. Then that will be equals to 161,57. So that angle that is formed there will be 161.57. Okay, I think that's an easier way to do it. If I've got a negative here, I know that the angle that I'm going to get will be in the second quadrant. In the second quadrant, we use the reduction formula, 180 degrees minus. So immediately just write 180 degrees minus and then you use a positive there. Okay, I know some of you will use it as a negative, and the right tan beta, beta will be equals to arctan negative 1 over 3. Then from there you say plus 180, which should still give you the same answer. Okay, right, some of you will get 18 and then they say this is a reference angle, then they subtract it, and then after subtracting it and then said, oh no, we've subtracted the angle from 180 degrees, the answer will still be the same, 161.57. okay, right, I think we are doing very well. Okay, now this activity, this next question says calculate the area of triangle ABC. Now, how am I going to calculate the area of triangle ABC? So I have point B there, there's the coordinate, point C there, and point A there. I need to calculate the area of this. I already know that this angle here is how much? 90 degrees. So I will not have a problem with that, because I know that the formula for the area of a right angled triangle is half of the base multiplied by the height. So I can use this one as my base and I use this one as my height. So I can use this one as my height and this one as my base. So already I've got these two. But now I'm given that BC, already the length of BC is given. Oh, that's nice. BC is given here. The length is given. It's 2 root 10. So what do I need? I only need the length of the height. So I only need one length. If I get that one length, I will be able to get the area. So I'm going to say the length that I'm looking for is length of AB. Length of AB. So the length of AB will be negative 9 minus 3 squared. It's negative 9 minus 3, and then plus 9 minus 5 squared. And the length of AB is going to be the square root of, so I'll have 12 squared is 144, 4 squared is 16, then I'm going to have the square root of 160, which is nothing else but 4 root 10, right? Now after I've done this, I know the other length is this, then I can then use the formula for the area, and I can say the area of triangle ABC will be equals to half of the base, which is 2 root 10, multiplied by 4 root 10, and then the answer is quite easy. I can use a calculator, but I don't need to. So half of 2 is 1, Then we're left with root 10 times root 10, it's 10. 10 times 4, it's 40 square units. Right? Because it's area, so it's square units. So the area of the whole triangle that we're having here is nothing else but 40 square units. Okay. All right. Now, the next question, it's write down the coordinates of P, the midpoint of BC. Oh, that's straightforward and very easy, because now I have point B and point C. I need the coordinates of this point. I can somehow write them here, because I can easily do them. It's 3 plus 1, it's 4. 4 divided by 2, it's 2. This is 5 plus minus 1, which is 5 minus 1. It's 4. 4 divided by that is 2. So the coordinates of P will be 2 and 2. So what I've done is the coordinates of P will be nothing else but 3 minus 1 divided by 2. And I've got 5 minus 1 divided by 2. Then the coordinates of P will be 4. So what did I do? It's 3 plus 1, sorry. So it's 4 divided by 2. And this is 2. Can you see how we make mistakes? The formula is plus. The formula for the gradient is a minus. And the formula for midpoint is a plus. And we divide it by 2. Why we subtracted here? It is because it's 5 plus minus 1. You see. So that's why we subtracted there. We get the coordinates of P, which is 2 and 2. Okay. Right. So can you see the word parallel, the word perpendicular has to do with the equations. So, and the gradient. So it has to do with the gradient and the equation. When they ask those questions, they ask it with the gradient and the equation. So you must understand the word parallel means the two gradients are equal. The perpendicular means when you multiply the two gradients, they give you -1. Okay. So sometimes they might ask you a question in terms of finding the gradient of perpendicular lines, or finding the equation of the line which is perpendicular to the other line that has been given through a point. Okay. So determine the equation of PQ if Q, now they say Q lies on AB and PQ is parallel to that, that's indicated. So what do I know about parallel lines? First of all, I know that parallel lines have got the same gradient, but in this case, I do not know the gradient of AC because we haven't calculated it yet. So first I need to calculate the gradient of AC, and then I use the point P. I already know what that point P is, 2 and 2. So what do I need for the equation of PQ? I need the gradient of this line. Because now I don't have the gradient of that line, I cannot calculate the value, the equation of PQ. And for me to get the gradient of PQ, I need the gradient of AC because the gradients of parallel lines are equal. The word parallel. Okay. So I must get the gradient of AC. So the gradient of AC will be y at C, which is -1, minus y at A. Then divided by the x over the x. So the answer that I'm going to get there, it's a -10 over 10. And the answer will be -1. Am I right? -1, yes, the gradient is a decreasing function, gradient negative. Now I know I must use the point P, which is 2 and 2, because I know that the gradient of now PQ will be equals to the gradient of AC, and that equals to -1. then I'm also using that point P. So I'll say y minus y1 equals to m into x minus x1. Right? So my y value remains, my y1 is 2, my gradient is -1, my x remains, my x1 is 2, then it's y equals to -x plus 2 transpose plus 2, y is -x plus 4. Now I want to check on my sketch if I'm correct. I go to my graph, my sketch. I know that my y-intercept will be at 4. My gradient is -1, which is a negative. The graph is decreasing, so we've got a -1. So I know now that I am correct. Okay, right. Now, the very last question for the day, it's a very easy, straightforward question. So I'm ending up with a very easy question, which every one of you can be able to do. Right. So now the question states, determine if this point lies on PQ. But now this question will also lie on what you got as the equation of PQ. So remember what we got in the equation of PQ was y equals to -x plus 4. So that is what is on the equation of that. So how am I going to write down? How am I going to know that that point lies on PQ? If it lies on PQ, it means that my left-hand side will be equal to the right-hand side. So, which means that this will be my x value, that's my y value. So I must substitute those values into the equation, because if it lies on that point, the two sides must be equal. My y value is 4. Already I can see it is not, because of I'm still going to substitute this value here. This value there. You see, x is minus 1/3. So I'm going to have positive 1/3 plus 4. And that answer that I'm going to get there will be 3 times 4 is 12 plus 1 is 13/4. This side is 4, and I cannot then say this side is equal to that. Okay, because 4 can never be equal to 13/8. So the easier way to do it will be to start with the left-hand side, and then I work out the the right-hand side, substitute it, and then from then I can then substitute my right-hand side. Then I can see that these two are not going to be equal. Okay, because in this statement it's also incorrect. That statement is also incorrect when I do that. Okay, so the value, so the point there does not lie on that. So what is my conclusion there is that point -1/3 and 4 does not lie on line PQ. Okay, right. So the analytical geometry in grade 10 and grade 11, as I say, it's between 13 and 15 marks in the grade 12 paper. We really need to start practicing it, because I know we have done it in grade 10, we've done it in grade 11. In grade 12, we are just going to do circles, and with the circles, we're not going to spend a lot of time in there, but the bulk of the work was done in grade 10 and grade 11, and the knowledge that you need for grade 12 analytical geometry, it's grade 10 and grade 11 work that you have done. So please go back, practice your grade 11 and grade 10 analytical geometry, especially the grade 11 one, because obviously the grade 10 one is incorporated into the grade 11 work. do that papers, those papers that you have written last year in analytical geometry, the worksheet that we have already sent that you need to also do, and then from there with that worksheet, you are going to be able to understand more of this work. And you can see it's just formula substitute answer. Formula substitute answer. Just understand the question, just understand what to do, especially questions that are based on determine the equation of the line, questions that are based on proving that the lines are equal, the area, properties of all those figures, your triangles, properties of a triangle, isosceles triangle, right angle triangle. Sometimes they might say, show analytically that this triangle is a right angled triangle. So you need to show that the one line is perpendicular to the other line, or show that it's an isosceles triangle, meaning that you must then see that the sides are equal by calculating analytically. So with the quadrilaterals, you really need to understand all their properties of a square, properties of a parallelogram. You're going to get those type of questions. You must be able to can answer them. So please make sure that you practice your grade 10 and 11 properties of all those figures, so that you are able to can answer questions that are going to be asked in analytical geometry. With that, I would like to say thank you so much for tuning in. Thank you.